NTU World of Wisdom. Welcome to High Impact Thesis. In this podcast, we speak with researchers from various scientific fields to talk about the motivation, goal, and potential impact of their research. We also want to give you a sense of how a Ph.D. is carried out with an emphasis on the PH, the philosophical aspects involved in pursuing a Ph.D. All right, welcome to another episode of the High Impact Thesis podcast. Today's guest is Alvin Chua. So, Alvin, welcome to the HIT podcast.
Thanks.
Okay, so as usual, in this episode, we're going to talk about Alvin's work specifically. We're going to talk then generally about his field. We also are going to talk specifically about his interests as a human being. So, it's going to be an exciting conversation. And we both are excited about having Alvin here, who is from sociology, right?
Humanities.
From the humanities, right? So it's quite a change from the science, engineering kind of science, I guess, that we've been doing. So we hope that our listeners, that you enjoy this conversation. Okay, so Alvin, introduce us to you. Who are you? What can we know about you?
Okay. Hi, I'm Alvin. I'm a second-year PhD student in the School of Humanities, specifically the history program. But my research is in archaeology, so it's a bit here and there. So we have my supervisor is an archaeologist in humanities. That's why I'm here. And my specific research deals with ceramics, earthenware from Southeast Asia. Singapore, sites from Singapore, and I'll be looking at sites from around Singapore, so Indonesia and Malaysia, for instance. So that's my research in a nutshell, and I'm sure we'll have time to expand on it in a moment.
Yeah, definitely. I mean, I'm really interested in understanding the history of ceramics. Is there a time that we think humanity invented or decided that you realized that you could turn clay into, these kinds of materials that have different properties, very different from the clay that...
Yeah, I think that's a good place to start. I mean,
how far back are we talking about?
Yeah, why exactly?
Knowledge?
It's been several thousand years ago. So the basic storyline is that there's this Neolithic revolution where mankind started going about with agriculture. And one of the things that you need with agriculture is pottery for storage of grains, for instance, or cooking the grains. And that's the general story of how ceramics came about. And you have that, for instance, in the Near East, the Tigris and Euphrates, Mesopotamia. Over there, Egypt and then the Indus Valley, and also in China. Southeast Asia, I guess, is a bit less well known as less considered as a cradle of civilization as compared to the other four areas, for instance. But yeah, you do have ceramics coming about also around the Neolithic period.
So the first thing, for you to create ceramics, the first thing you need to invent is fire, I suppose, right?
Yeah, you need to fire up the ceramics too.
Then the next step is really to know the process, like how long you need to keep it at a certain temperature. I guess that's... As in, the main two things are earth and fire, am I right?
And clays, water, and you have what you call temper, which is things that you add in. For instance, sand, which changes the property of the clay. So, for instance, it may make it more resistant to fire, to heating. So when you fire the ceramics, they won't crack and break up. For instance.
And what's the current theory? Do we know if these methods were organically developed, or were they transferred from other regions?
That is a very tricky one, because there's, I guess, a kind of debunked theory about diffusionism, where you start at one center and it just diffuses all over. So I think the current one is that it's not a one-way street, but rather it when things travel away from wherever it starts or wherever it was made, things come back as well. So it's a process. It's much more complicated because human beings learn and adapt. So they learn from others as well at the same time as when they teach others, so to speak. So in Southeast Asia, one of the theories is called the Nusantara and NMTCN, Nusantara Maritime Trade and Communication Network, where one of the things that they looked at was ceramics. So you have specifically in the decorations, so you see a set of ceramic patterns, not entirely the same, but some bits here and there being found all over the region. And the main idea basically is that the sea acted as a conduit for the flow of ideas, information, trade goods, and so on, including pottery. So the ideas of pottery and their decorations were transferred all across, and that was because you have the sea that facilitated this kind of transfer.
Okay, and so we know like there's certain types of what's the word?
Ceramics.
Corps, like agriculture.
Crops.
Crops, yeah, that are unique to this part of the world, and you mentioned in the beginning that these things tend to develop, parallelly with agriculture, right? So are there like specific, tools and ceramic, containers that have unique style only to Southeast Asia, for example?
Southeast Asia.
Or East, let's say.
East.
Yeah.
You mean like decorations, for instance?
Right, or just functions, let's say. Like, I don't know. Just makes it unique or different than other parts of the world.
Yeah, probably the decorations, if you look at the not single decorations, but rather a group of the decorations, which has been called the Sahuin Kalane ceramic complex, where you have a set of decorations, but I can't recall offhand what types.
Right.
But yeah, they are in a group. But as I mentioned before, when they traveled around via the sea, so again, here is where human agency comes in, because some of the motifs would be chosen specifically by certain people, and then some other people would use different motifs, but still in the same set of decorations within. Yeah.
Okay.
So I think here it's more of decorations that I would say is a bit more unique. Whereas for forms, for instance, you would have, say, like cooking pots, and that's something you would find elsewhere as well. The other thing, I guess, would be the materials that were made.
I see.
The materials that were used to make these pots, because that goes back to geology. So what kind of clays are available, and that's the kind of ceramics you'd get based on the clays that are available in a certain region. Yeah, so that's kind of where a bit veering towards my own research, looking at the.
Sorry, and how far back is this? Like the period you're studying?
The period I'm studying is in the historical period. So for Singapore, 14th to 16th centuries. So it's not prehistoric way
I
back.
See. Okay.
Because for Singapore, as far as I'm aware, we don't have prehistoric sites. There's one potential site, I think, on the northern part of the island, but chances of any excavation being done there is close to zero, because it's on an army firing range. Okay. That's not going to happen. And as far as I'm aware, for instance, in Malaysia, neighboring Malaysia, you have prehistoric sites mainly in the cave areas. So that's another thing that you don't really find over here.
Interesting.
Yeah.
So when we talk about ceramics, can you give like a one-line description of what we're talking about? So I'm assuming that the tiles in homes, for example, are ceramics as well as...
Yeah. So I guess at the most basic, you would call them fired clay.
Mm-hmm.
So for instance, you even have like, tiles, roof tiles, for instance, that would also be counted as ceramics. So that's ceramics from, I guess, an archaeological perspective, because if you ask a material scientist, ceramics would be something quite different.
I see.
I think. But in archaeologically speaking, tiles like roof tiles, floor tiles, we would class them as building materials. So it could be ceramic building materials or architectural materials. So you have those, and then you have, say, bricks. Yeah, bricks would be ceramics as well. But at the same time, you have mortar, which you use to join the bricks together. So those are not fired clay, but you would call them, class them under these construction materials.
Okay. Mm-hmm. And were they traded in the region, across the region?
That's
Okay.
For earthenware, it's a bit more difficult because you have the tempered earthenware. So these are the earthenware which you put in inclusions. So those would, the hypothesis is that they were made locally, but it's difficult to test that hypothesis because based on ethnographical studies as well, the pots would be fired either in a bonfire, so you stack the pots up and you just fire them, or you dig a pit in the ground and put your pots in and fire them. And in the archaeological records, they don't leave much traces as compared to, say, a kiln. And you need kilns for ceramics that are fired at a higher temperature. So those are the things like porcelain or stoneware, and those they are traded around. But before I go there, there's a type of earthenware that is traded around, which is called fine paste ware. So these are, unlike the tempered earthenware, they are without those tempers. And the two main centers of production that they found are in Java and in southern Thailand. And those were traded around. So you can find those even in Singapore. You have, in the Singaporean sites, you have these shirts of fine paste ware. So that's for the earthenware. And then for the higher fired ceramics, you have the Thailand. They did quite a bit and was exported around. I think it's the Cambodian, the Angkorian ones, Vietnamese ones as well. And these ones, you find them in addition to the Chinese porcelain in shipwrecks, for instance. So you have loads of shipwrecks around the South China Sea, and those, they do contain quite a bit of Thai ceramics. And the reason why you have Southeast Asian high-fired ware going around is because of what they call the Ming Ban. So that was during the Ming Dynasty around 15th, 16th centuries, where China decided to close their doors. And that more or less stopped the flow of Chinese porcelain, although you have traders doing it illegally. But based on the research, they found that in the shipwrecks from this period, there was much less Chinese porcelain around, and instead you have a lot of Thai ceramics. So when the Chinese closed their doors to porcelain export, there was still a market, so it was filled in by the Thai, and the Vietnamese, so the Southeast Asian ceramics.
Interesting. So is there something about the China is the term for Chinese porcelain, right? Or are they different?
I would just call them Chinese porcelain.
Okay. Because growing up, we had a lot of these What I now realize are ceramic things that we just call China. And a lot of them, right? So I'm just wondering, this technology seems to be you just put things in a kiln and you control the temperature and you make them. So is there something special about the clay that they use? The Chinese porcelain?
So for Chinese porcelain, they use kaolin.
They use what?
Kaolin.
Kaolin is a type of clay.
Yeah, a type of clay that you would be very suitable for porcelain, because for porcelain, the difference between porcelain, stoneware, and earthenware is that porcelain is fired at a much higher temperature, above 1,300 degrees Celsius. And not all clays can withstand that kind of temperature, because if you fire, say, any random clay, it might just break. So for kaolin, it is able to withstand to 1,300 degrees Celsius, and that is one reason why they can be used for porcelain, the Chinese porcelain.
And in the past, I'm wondering, would get you to that temperature? I'm wondering how they...
Yeah, you also need the kilns for a start. I can't recall offhand for the porcelain, Chinese porcelain, but there are different types of kilns. So as I mentioned before, you have the bonfire and the pit. So that's the most basic one, which is not a kiln. But the next stage would be updraft kilns. So basically, they are a tower. They are towers, and you just stack upon your ceramics one after another. So the heat source is from underneath, and it flows upwards because heat travels upwards, right? So for that, you can get a higher temperature because it's in a contained space, but the firing is not as even as you would like it to be. So the lowest part would be fired at a higher temperature, whereas the ones higher up would have less heat. Then the next development is called a cross draft kiln. One example is the dragon kiln in the Taoguang pottery jungle, which is close to NTU, if anyone has been there.
Where is it, NTU?
Just outside NTU, actually.
Oh, okay.
But so with the updraft kiln, it goes upwards. The cross draft kiln, it's something like vertical.
Horizontal.
Horizontal.
Okay.
Yeah, so vertical, horizontal. So in Southeast Asia, they started building that along riverbanks because they just made use of the natural inclination of the ground to build these cross draft kilns.
Okay.
And then the next stage was so what they did was they just dug through the ground, put the ceramics in and fired them. The next stage was where they reinforced the dome with mud or other materials, because that is quite prone to collapsing, so you need to reinforce them. And then the third stage is where they just built the kilns above ground. So in ground to kind of a transition, and then above ground. So with these cross draft kilns, you have the firing chamber horizontally, and then you have your fire box in front where you have the fire, and the heat will go through horizontally, and that allows a more even kind of firing and higher temperature as well. So that's how they would have achieved those kinds of high temperatures.
It sounds like a blast furnace in smelting, like
it's something like that.
Kind of helps.
But the thing is, with blast furnaces, the heating is quite fast. So with ceramics, you don't want to heat it that fast. You want it to be a bit slower. So that's one reason why the blast furnaces, the technology is slightly different and not that suitable for firing ceramics, where you need to go a bit slower and more gradual.
I see, because I guess in ceramics, the rate at which you actually provide the heat controls the properties of the final product. It's one of the things, right, that you use to control. Okay.
And were these processes documented in any form? The records of...
I think the Chinese ones... Let's see. Because that kind of I don't recall offhand, because for those would be quite those things would be quite technical, and I can't remember offhand whether we have for the Chinese ones. They might be, I'm not that familiar. Because for instance, I remember, well, this is another case, the Romans. Because for my master's, I did, for my master's thesis, I looked at Roman mortars, and you do have records, a treatise by Vitruvius, famous guy for architecture, and he talked about the different kinds of mortars and how do you slate the lime and all that. So that I know they have it, but I don't recall offhand for the Chinese, for instance. Southeast Asia, I don't think they have any records, that kind of technical text for the for firing high-fired ceramics. So a lot of it would be, for Southeast Asia at least, you would rely on archaeology. So the kind of kilns that have been left over, that's one. And then if it's still in production, you might go for ethnographic studies. So for Chinese porcelain, for instance, you have Qingbezhen, which is quite a well-known porcelain capital, and they're still producing the porcelains. So for that kind of situation, you don't really need the text because you have people still making them.
I think that also would be the primarily mode of teaching and transferring the knowledge. Just firsthand. Okay, so I want to gradually get into what you do specifically in your PhD.
Sure.
So my first question is there like a research question that you specifically trying to answer in this PhD? Have you got to that part yet?
It's kind of, well, to some extent, I guess it would depend on what kind of samples I'm getting. So that's a bit of playing by
kind of
ear
dynamic.
still.
Okay.
Yeah, but I think what I would like to look at is the kind of what sort of raw materials, I guess, at the very basic were being used. Because one issue, I guess, with the state of scholarship in Southeast Asian earthenware is that they've not really looked at the materials in the sense that the raw materials of the ceramics. So a lot of the studies have been focused on the decorations and the forms of the earthenware. But to look at it under a microscope, for instance, or using chemical analysis is still, I suppose you could say that it's still at the beginning stages. So at a very basic, I guess, would be to look at these ceramics, this earthenware from the different sites and see what their mineralogical and chemical composition would be, and then try to move forward from there. So,
and are you building upon someone's work, or are you starting from scratch? I mean, in your research group.
So I guess
no one starts from scratch, of course.
Research group. That's I don't think that's what your research. It operates a bit differently from the sciences.
I see.
Yeah. So I think it's building up from what has been done. So, i.e., that for the Singaporean materials, for instance, use what you would get. I suppose the process would be you excavate, and then there's post-excavation work where you do you record all the finds. So in this case, the earthenware and the ceramics that I'd be interested in, put it in a database. So that's where you get all the basic information. For instance, whether there's a decoration, what kind of form the ceramics would be, whether there's any surface treatment, and so on. So that would be, I guess, for the basis for what I'm doing, because you can just pull out random samples and do chemical analysis or look at it under a microscope. But without that kind of bigger context, then it's not really going to do much, I think. So yeah, it's building up on the more traditional, I guess, archaeological approach where you look at forms, decorations, and all that, and then looking specifically at the raw materials. So yeah, that's in that sense, it's working, building up on something previous that has been done previously. But at the same time, I guess it's new in the sense that no one has really looked at least for petrographic thin sections in the Singaporean material. There have been one or two studies on the chemical composition of the fine pasteware, especially because that's the one that gets traded around. So that's the one that people are slightly more interested in because of the trade connections. Whereas for tempered earthenware, because the assumption is that they will be made locally, although they might have been traded as well, but not as extensively as the fine pasteware. So because they are thought to be made locally, there's less interest in it.
Okay.
So in that sense, yeah, for Singapore, but in Southeast Asia, there have been works done on looking at using petrographic analysis, which is what I'm doing, to look at materials from other places, other sites. So I think the Thais do have some papers I've come across there. Philippines, I'm not that sure. Indonesia, I don't think I've come across that many. But I think it's mainly Thailand and maybe Cambodia that I've come across papers that look that apply petrographic studies and some other scientific analysis to the materials. But that's for geographical terms. In terms of time period, it's usually the prehistoric materials, so the Neolithic ones, rather than the more historical period that I'm looking at, or even colonial period. Although there is a PhD thesis on a site called Banten Lama in Indonesia that uses thin sections to look at the earthenware, and then she also looked at residual analysis, looking at the phytoliths, and I think textual evidence. And the big picture for her was to look at the dietary practices during this particular period, which is the colonial period. So how the Dutch and the local Bantenese influence each other in their dietary habits, which is quite an interesting paper. Thesis.
That sounds interesting. So you're looking at what they eat from in order
not,
for you to tell the habits of
not
the people
that them.
Okay, yeah, but
that particular person.
I'm just saying that it's quite an interesting study, as in it looks like you wouldn't know that you could use ceramics for that purpose.
Because, for instance, one of the things she looked at was alcohol consumption. So, for instance, the Dutch they drank, whereas the local, the Bantenese elite were Muslims, so they didn't drink. But also she looked at how the cooking methods. So you have, say, different types of ceramic vessels to be used to cook different dishes. And she was looking, I think that's true, the forms of the ceramics.
So if I get you correctly, then at some point, the locals will be using tools that the colonizers brought, and vice versa.
Yeah, it's entirely possible that so they learn from each other how to cook different dishes and then they adopt.
Interesting.
So that's like hybridity in action, I guess.
So for you specifically, you're saying that you're trying to understand the raw materials that people use in different places. So your study is a comparison across different geographies, am I right?
That's one direction that could take place.
Okay.
Assuming that I get the samples, because it's dependent on the samples that I'm getting.
Oh, I see. Okay.
So that would be one way to go forward, I guess. To look at the different raw materials that people are using, and also because with thin sections, you could look at some of the forming traces of forming techniques, whether they were coil built or they're pinched or slab built. So some of these techniques would leave, for instance, it would affect the orientation of your grains or the type of voids that you would get in the clay, and you might be able to see some of these in the ceramics. Or even there's also clay mixing, so people might mix different types of clay together, and sometimes you get to see, you might be able to spot the different clay mixtures, but that's also going to be quite difficult. It's just going to be a challenge, but possible.
Are there any big or large-scale uses for ceramics in this region? For example, I know that ceramics can be used to make pipes, for example. Can you have a whole water distribution system made of ceramic pipes? Was such a project on such a scale ever done for ceramics?
Yeah, I think piping, not that I'm aware of. Because, piping is definitely one of the things that you could do, but I don't think I've come across any water systems with that kind of clay pipes. But the biggest usage, I would say, is for cooking. So cooking pots, because that's something that before you have metal is something that's not that common as it is today. So for cooking, you usually won't have metal vessels, and then for storage, they didn't have plastic, so pots would be the go-to thing.
I see.
So you have cooking vessels, you have probably not so much like eating like plates or dishes, because I don't think we've seen much of that. But the possible reason why that's the case is maybe people in the past ate out of things that are how to put it,
Disposable?
Yeah, disposable, like banana leaves,
right.
So biodegradable basically. So you don't have ceramic plates, or at least you don't see them. I don't think I've seen any.
That's quite efficient, actually.
Yeah.
But it's a lot of work, right? Because you have to get the leaves every day and throw them away. I don't know how in your culture did you use leaves, or is it?
No, I mean
in the past, not now.
Yeah, but that's not common. It's not a green environment, right? Don't have a lot of leaves around.
No, but you gotta have bananas and stuff.
So so cooking pots. The other one would be vessels for storing water, and that goes. So the rationale for that is to keep the water cool, and earthenware is porous, so that means that water is able to evaporate through the clay body, and because of that, it keeps the water cool. So it's kind of like a pot sweating in a way to keep the water cool. So you just instead of refrigeration, you have cool water in earthenware pots.
So just to be clear, earthenware, stoneware,
porcelain,
and porcelain. So the difference is in temperature, right?
Yeah.
The temperature at which it was fired.
Yeah. So that's the main difference, I'd say, because there are other differences. So for instance, with earthenware, normally, at least the local ones, they are not glazed, as opposed to, say, stoneware or porcelain. You have glaze, which makes it not permeable to water, so it gets rid of the porosity. So for instance, you have stoneware which it's glaze, and one reason why they want it to be non-porous is because it stores other types of liquid other than water. So like say fish sauce or alcohol for fermentation. So in those kind of cases, you don't want the liquids to evaporate out. So, and then I guess you also have like forms. So for instance, forms and functions. So for earthenware, cooking pots, because it's more resistant to heating than say to being over a fire, direct heat, as opposed to say stoneware or porcelain. And supposedly food tastes better if you cook it in earthenware pots.
Supposedly, yeah, I hear that a lot.
I actually tried it. It'd be an interesting experiment to have a blind taste test.
Yeah.
You haven't tried it?
Not yet.
I think maybe you should do that since you're in the field. But I mean, I did eat from earthenware pots a lot, but I'm not sure I remember the difference. But it sounds maybe more, more environmentally friendly. Maybe not. I actually don't know which is more friendly for the environment. Having every society make pots on their own, or just having it outsourced the way that society is currently organized, where you have one part of the world make the pots pretty much for the rest of the world, for example.
I suppose one potential issue with that kind of going to earthenware pots instead of whatever we have now is pots are made using clay, and so you need a source of clay, and if you keep taking out the clay, then eventually it's gonna finish. Right. And then what do we do?
I don't think we can run out of clay though. I feel like there's gotta be a lot in the oceans and seas or whatever. I don't know what is clay, to be honest, in the definition, but I suppose there's gotta be a lot of it, right?
But at the same time, well, the other reason I guess why earthenware, why pottery, you find it so much in the archaeological record is they break easily. So once you break it, you just throw it away. And then once you throw it, it doesn't decompose anything, so you find them still there. But yeah, I think, well, because clays, you do need, it is in certain areas that you have them. So it's not anywhere that you just dig a pit and there's clay. Because normal soil, for instance, does not have that kind of clayiness.
It needs to be like
it needs to like sticky,
something like that.
Because the thing is when I guess it's called malleability, where you can mold it into a shape.
Right.
Whereas with normal soil, it doesn't hold. So there are like clay deposits that could be exhausted, I guess, with any other natural resource. I think it's in Africa, if I remember correctly. There have been ethnographic studies about the potters, and one of the things is that with potters, you have like a master and an apprentice, and then it gets passed down from one generation to the next. And they would have clay deposits that they would go to. And one of the things that they do is, if I remember correctly, is that they have like rituals at the clay deposits. So in a way, it's still seen as something like quite, I suppose, like natural spirits and kind of animism attached to the clay resources. So it's quite, I suppose there's kind of respect, I suppose, for the natural resources. Whereas if it becomes commercialized, it's just going to be like everything goes. So I don't think it's a nice idea to have clay, using clay pots being or clay containers replacing plastics. But at the same time, I'm not sure that the commercialization of these kind of products would just kill it.
Because they are biodegradable, right? Is that right?
They're not biodegradable.
Oh, they're not.
But at the same time, they don't pollute the ground.
Oh.
So they're inert basically. So they're just there, waiting for someone to find it.
Oh, okay. So, I didn't.
So
I
they
didn't
don't pollute or they don't do anything.
Well,
So
speaking of that, do you have to do your own excavations? Like, do you go around the region and,
I guess the good
or
and
not yet?
the
or-
good and the bad thing is that I don't have to, because I would like to, but most of the things I'm doing would be post excavation. So for instance, the Singaporean sites, they've been excavated. So now some of them are in the process of data entry, and then I'll be doing the analysis. And there was, well, when I started, that would be 2 years ago, the plan was one of the sites that we planned to look at was Bagan in Myanmar. And then with the political situation, that's a no-go.
Right.
So otherwise that would have been possible. Not excavation per se, but at least some field work. The other one is Indonesia, Trawulan. Although I'm not sure what's going on now. With COVID, so we'll see how that goes. But for most of the sites, the Singaporean ones, the materials are here. They've already been excavated, and some of the ones from around the region, my supervisor has them. So
I see.
Not really excavations. So it's more of post-excavation work, I'd say. Yeah.
And are they available for the public to observe, like in any museums?
Museums. Glad you asked that question.
Okay.
The thing is, the ceramics that we have are all like in sherds, so they are really small, tiny fragments. And it's difficult with museums because they would prefer nice, complete vessels that you could exhibit.
Something pleasing to the eye.
Yeah. So for these sherds, it's a bit they're less keen, because chances are they'll end up in the storage, and storage space is another issue that museums they have lots of other things to store, so shirts are not really on their priority, I guess.
Okay, that's too bad, I guess.
Yeah.
And how do you actually study? Do you use a microscope? You've mentioned a microscope a few times. You've mentioned chemical analysis a few times as well. And I'm wondering, when you are looking at these properties of past such ancient properties. Oh, you brought something?
Yeah, I brought something.
Okay. I wish our listeners could see, but imagine him holding a couple of things in his hands.
So these are mounted mounts. So they're not from the same project. So but just for illustrative purposes. So what you do is you cut about 1 centimeter of the material. So these are actually European porcelain. About 1 centimeter, and then you put them inside this epoxy. And then what you need to do is you need to expose the surface. So you probably polish it a bit. And if you just hold this to the light, you can see it. You can see like the light moving across the epoxy. And then there's a bit of a difference with the what's it called?
What are we looking at again?
So the light is, you can see the light going across the epoxy if you just move it a bit.
Oh.
And then there's the exposed surface, which is slightly different. So the top is
this.
So here on this surface.
Oh, on this surface?
Yeah. So if you put it to the light,
and
you just move it a bit, you can see like the reflection, and then the ceramic itself is exposed. And then what you want to do is to polish it. You want to grind it down a bit to smoothen it, and then polish it so that it reflects light. So this is for mounts. And then you can put it into a SEM EDS and do chemical analysis.
A SEM?
Sorry?
A what?
SEM, EDS.
So this is a machine?
Yeah, it's a machine that does chemical analysis. So scanning electron microscopy, energy dispersive spectroscopy.
Okay.
So basically what you do is you bombard the sample with electrons, and then there'll be electrons. What you want to look at would be the backscatter electrons, which is captured in a detector, and that tells you what kind of chemical elements are there in it. So for
It's like X-ray, like crystallography.
no,
It's unrelated.
You're not looking at the crystal structure. So that would be XRD, X-ray diffraction, which would be a different process, which I'm not doing.
Oh, okay.
But this one is basically just electrons firing down and then releasing other electrons captured in a detector.
Okay.
So for clays, you would expect to get silicon and aluminium. So those are the two main elements that we would look at. And then you have things like...
Say that again. You when you bombard, what are you looking for? What do you see after you have successfly
Your signature, right?
So the spectrum in the on the software. Yeah.
Oh, so the spectrum tells you what materials or what elements are in the...
Because you would have peaks.
Yeah, right.
And then you'll be looking at which peaks correspond with which kind of elements.
So you have a chart that tells you that this element is that, and then when you look at it, you compare with that chart kind of thing.
More or less, yeah. Because I don't think that's a standard, but because people have done this kind of analysis before, so there would be references as to what, say, the peaks of silicon or peaks of aluminium, where would they be about? So silicon and aluminium, and then probably you'd find some sodium, potassium, and calcium, and that's because one of the things they add to these kind of porcelains is what they call flux, and one of the kind of fluxes would lower your I think it's the vitrification point, where the temperature that's needed for it to vitrify and turn into porcelain. And that one of the common things that they use for flux is feldspar. So feldspar, you have three different main types of feldspar, where one has the potassium, one has calcium, and one has sodium. So those three, you'd probably looking at those. And I think there are a couple of other elements. And then for things with these glaze, so for instance, this one is a blue, probably you'll be looking out for cobalt, because that's one of the common pigments that you use for blues. So that's for chemical analysis.
Wait, so let me just... When someone says clay, is it based on the chemicals or elements found there, or based on how those elements are arranged?
Yeah, I suppose it depends on who... Yeah, I would say in terms of elements, you have silicon and aluminium. Okay. But then if you look at the crystal structure, then you have different types of clays.
I see. Okay, so the original elements, the elements that make clay are the same, so to say. But then you have a few things thrown in there to kind of form different kinds of
not so
clay.
Much throwing different things, but rather the structure, the crystal structure, so how they are arranged. So, for instance, you might have them in sheets, or you might have them as a single... I can't remember offhand the terms for it. A single chain or a double chain. So you have different types of clays. Kaolin, if I remember correctly, is one of those sheet kind of clays. I think it's a phyllosilicate.
Okay. So because you mentioned there are a few, like you were talking about cobalt just a moment ago. So I was wondering whether different kinds of clay contain different kinds of additional
for that,
things.
Trace elements, for instance, but you probably would need other kinds of analysis and analytical techniques. So, for instance, you have ICP-MS, which stands for inductively coupled plasma mass spectrometry, which would be able to look all the way to trace elements. But the cobalt is not part of the clay, it's part of the pigment that gives it the glue.
Oh, I see, okay.
Yeah.
You have other stuff.
Oh, yes. That's the next stage. So for instance, so here you have the mounts, and then you have thin sections. So for thin sections, you don't have to polish it. So you just need to grind it first. So the polishing comes later. And then what you do is you mount it onto a glass slide. So you put another type of epoxy, leave it overnight. And then the next day when it's dry, you cut it. So about, say, let's see, is it 1.4? I think it's about 50, no. It's about 50 odd microns. Can't remember offhand now.
When are you cutting?
Sorry?
You said you're gonna cut here?
So yeah, you
somewhere?
cut, which is about, I think, 100 microns over here. So you're only taking a small piece of it. So you'd have a big chunk left over.
Yeah.
So I think, if I remember correctly, there's about 100 microns. And then you want to grind them down.
So what are we looking at here?
So you grind them down until they are 30 microns. And then you polish them. So what you're looking for is the minerals. So because at 30 microns, you have the quartz would be about yellow, a pale yellow color. And you know that you use the quartz as your kind of your marker because they are the most the most common mineral grains that you find in ceramics here. Because chances are people just add sand to the ceramics as temper. And what you're looking at would be, at 30 microns, you have interference colors, and then you know that you're there. So apart from quartz, you'd see whether there are other minerals as well. So the idea is that you get sand from, say, a river, and that would be around the end of the river. So when the river passes through different areas, you would take different rocks and mineral grains along with it. So the idea is that if you know the geology, you would potentially be able to trace the provenance of whether you could determine, for instance, whether it's locally made or something that was imported. Because if you see, say, minerals that are not found in the local geology, say if you find, say, volcanic grains from volcanic rocks and in an area without volcanoes, then you might be able to hypothesize that these things came from somewhere else.
Right. So
that would be one of the things that you look for in the raw materials. And then, as I mentioned also about the type, for instance, like the kind of voids, or maybe you could see clay mixing, so technology as well. So this is a thin section, and you would put it under a polarizing microscope, because that's when you'll be able to look at your interference colors. So this is about 30 microns thin. So from this bit, you cut out a bit, and then you grind it down. So it takes a bit of time, but I'm quite happy that it's done using machines here.
So what you have right now, this is the actual sample that you can put under a microscope now and observe.
Yep. So this is a finished sample.
So this is all created by machines.
Yeah, more or less, because the part where cutting the 1 centimeter piece, you could put it under a diamond blade, but for the most of the earthenware, I did it with a jigsaw, because they're quite fragile, and the diamond blade is just a bit too aggressive, and it might just destroy the whole thing. So that was done by hand. And then you have the casting and the first grinding down to expose the surface, and that was done by hand. Then you have the grinding or lapping, that was done by machine. The polishing is also done by machine, which is great because if you're doing it by hand, that's gonna take forever.
And how long does it take right now with the machines?
With the machines, about, I would say, 1 to 2 weeks.
1 to 2 weeks?
2 weeks because you probably need... what we learned is that for the earthenware, it's best to dry them over 2 days because they are porous, and when you want to make sure they are totally dry. Because if they're not, what happens is at some point of time it will delaminate. So delamination is something like this, where you can see it starts to peel off, and because it didn't stick well, the sample didn't stick well to the glass slide because of the water content. So we want to avoid that. So 2 days for that. And then the rest of it is, so that would take, if you're lucky, it's 1 week. 2 weeks because you have things like delamination. And there's one occasion where I accidentally broke the slides. 5 of them.
5 of them.
Yeah, so that's so that really sets you back a bit. And you need to redo it again. So redoing, you just so that could take some time. Right. So about 1 to 2 weeks for a set.
How new are these methods? Are they?
Oh no, they are quite old traditional methods that have been done, tried and tested. But in Southeast Asia, it's not been utilized as much. So, for instance, in the UK, they do it quite a lot. In Europe, they also do it quite a lot. And it's old because I think it was in the 1940s where you already have publications for ceramics being studied with thin sections. And for those articles, now we have photographs, which is so easy. Back then, I think the scholar actually drew what he saw. So it's like, wow. Yeah.
Okay. So, and are these available online, like for people to see them? Like, can you provide them a link or something?
Not yet at the moment.
I mean, not these specific samples, but maybe something similar.
Where do you get them?
These are from the sites in Singapore. Let's see. I don't think you have articles with thin sections.
Or maybe they can just Google it, I guess.
Yeah, Southeast Asian ceramics, thin sections, those would be the keywords. Because there are articles scattered here and there. I think some of them are open access, so they can have a look at what has been done. But I don't think there is a central repository for Southeast Asian materials, because partly maybe it's not really done much. There is one, let's see if I can recall. It's called the Levantine Ceramic. I think it's called the Levantine Ceramic Project, and that looks. It's a repository for thin sections, mainly thin sections of ceramics. Thin sections have been done for ceramics around the Eastern Mediterranean area. So that one is kind of like, I think, a nice model for if ever in Southeast Asia we get to that stage where there's lots of thin sections being done. But at this point of time, it's just a few here, a few there. Okay. So not yet.
All right. So you've got your own research topic and your own research goal, but can you tell us a bit more about the field? Where are you guys intending to go as a field? What is the end game? Or what are some things that you think would be breakthroughs in your field if this were
breakthroughs in
and we haven't really had sociology, not sociology, right? Archaeology. Archaeology. We I don't know what are the meta questions that archaeologists want to address.
I think for Southeast Asia, this particular early historical period, probably there isn't yet that kind of like meta question. I would say that the prehistoric period with what's it called, the Nusantau that I mentioned earlier on, they've been looking at decorations and to some extent vessel form. So maybe in that particular area they could look. There is kind of a bigger overarching question that thin section petrography and scientific analysis could help to complement what has already been done in the past. But for the ones that I'm looking at, the 14th to 16th century, I think what I'm hoping at this point at least is to have something started and then just gradually build that up, and then maybe somewhere down the line to think about how all this can fit together. So I think at this point of time, it's not so much about building a house, so to speak, but rather getting the bricks.
Right.
Yeah, getting the bricks and tiles and whatnot, and then build the house. Because at this point, I don't think we have the bricks yet, or at least you have some here and there, but not sufficient for that kind of thing.
What is the most exciting thing you've discovered in your research? Not through reading, not you as in what have you discovered or invented, but like what is something that you were awed by when you read or saw about ceramics, or how people use them, or what do we use for? Anything?
Can be archaeology in general, or specifically ceramics?
Just specifically ceramics archaeology.
Okay.
Is there anything you saw that was fascinating that you would like to share with our folks?
Okay, let's see. No, it's not directly related to what I'm doing. Maybe a bit more. Yeah, it's a bit more related to what one of my seniors is doing. But I think it was probably a couple of months back that and it's not in Southeast Asia, it was in somewhere in Europe, where they looked at I think latrines and the ceramic like latrine pots, and they found evidence of some kind of parasites. Yeah, through the waste, human waste.
It was still stuck.
It was inside the things. Yeah, in the pot itself.
Oh, so they did a DNA.
I think they did microscopic analysis.
Okay.
Which I thought was quite interesting.
It is, yeah, definitely.
Right. It's always fascinating to hear from people who have studied the past, because we only know a small portion. Those are also studying historical archaeological things. We only study a small portion of human history, right? And I think it's always nice to hear what people did in the past, because I think to some degree it's a repetition of the skills, right, or small steps that we take to do the same thing that other people did but slightly differently, because ceramics are still very cool today, right? They're still a thing. Like, people are still making lots of things out of ceramics. I think there's still debates about whether it's better in some instances than in others, right? So I think the skills and knowledge about what people did is definitely very useful. So thank you for sharing with us about ceramics and history of ceramics, okay? So we are moving toward your hobbies.
Title section.
So, you do a lot of studying the past. What keeps you going in the present besides the research?
I guess, I would describe my interests or hobbies as more on the mundane side. For instance, I enjoy taking public transport. think I mentioned this before.
Okay.
It's an interesting hobby.
Okay, it's a cheap and interesting hobby.
I mean, I guess where it kind of started would be when I did my master's. So one semester was spent in Rome, and it was at La Sapienza. So we have classes that for some reason ended at rush hour. So in the evening, the evening rush hour. I'm not sure why they arranged it in such a way, but okay. So I live slightly outside of the city center, so I need to take, there's a metro, Castro Pretorio, I think that's Policlinico, that was the one closest to the university, and that's the blue line that takes you to my stop, which is Marconi. And because it's rush hour, the ride from Policlinico to Piramide is quite crowded, and it's like, that's pre-COVID time, so everyone's like squashed like sardines in a can. And then lots of people will get down at Piramide to take the Roma Lido railway, so further out of town. So what I enjoyed doing was to take the train, the metro from Policlinico to Termini, and then I think it was the 714 bus, which goes to close to my place. And because that bus starts at Termini, you most likely get a seat. It's more or less like empty when you get there.
Stop, right?
Yeah. So after that, it starts getting crowded, and it's very nice because it just the bus winds through Rome, and you get to see all of these nice monuments and churches and so on.
It's quite cool.
Yeah, exactly. Yeah. So it's not the same in Singapore, but but it's doable. And I think that's it's.
You still do that here? Or
when I go out, because I think one thing I guess I notice is that people are always on their phones, so they don't actually look outside of the bus and see what's going on, and I think that's a shame because that's something I like to just looking out and seeing things.
Right. I mean, I agree with you. Whenever I have time, I just prefer the bus because you can just look outside.
It's time to. I take it as kind of like time to wind down a little as well, and it's nice if you're not in a hurry. Then that's ideal. Right.
What else?
What else?
Anything more?
Like cooking in some of this pot.
Cooking is another thing that I guess another mundane thing that I enjoy doing, but not so much in recent times because I'm living in halls and the only cooking thing you have is a little electric hob.
And you can still get creative with those.
Although then the other thing is you probably need a fridge to store the stuff.
Yeah.
So so what I've been reduced to is just boiling extra vegetables. Because the food here is I find that it lacks like just that extra bit of vegetables, so that's what I do. But what I enjoy, one of the things I enjoy doing with cooking is using up leftovers. So one example is when I did field work in France. For lunch, they usually have catered food, so they get food from a caterer and eat. And often there would be leftovers, and dinner we cook on our own. So dinner is usually more or less planned by some of the people. But during the weekends, for instance, you'd have quite a bit of leftovers, right? I try to use up the leftovers and make something out of it, which is fun because it's also a challenge, right? You need to think what am I going to do with these? So, for instance, we had once there was a chickpea salad, and there's a whole tub of chickpeas basically. So what I did was I kind of mashed chickpeas up. And the idea is to me like falafel, so not really falafels, but falafel-like substance. With chickpeas.
This is the idea behind many dishes actually across the world. Yeah, falafel is definitely one of them. The ratatouille also is like another dish where they just use leftovers. Yeah. All right.
So I find it fun to just figure out how to make use of all the leftovers.
So your master's was in Europe, or was it?
Yeah, it
okay.
was an Erasmus Mundus
Erasmus,
masters.
right? Yeah.
So I was here and there.
Oh, that's cool.
Studying ceramics. Was it?
No. That was
Okay.
on archaeological material sciences. So it's more or less specializing from archaeology to, well, a subfield, I guess, of archaeology. So archaeological science. So for the first 3 semesters, you're more or less looking at the different techniques and the different materials that you could analyze using scientific techniques. So those were more introductory because for most of us were from an archaeological background. You have a few people from the sciences, but at the same time, so for the archaeologists, we would not be that familiar with scientific techniques. For the scientists, they might not be familiar with archaeological techniques, or even the sciences. Because for the sciences, we focus on chemistry and geology. So the first 3 semesters were more or less looking at the various things. And then it was only with the thesis that you focus on a specific project. And I wasn't looking at ceramics, actually. I was looking at Roman mortars.
Okay.
But the techniques were similar in the sense that there was SAM-EDS, the thin section petrography. And then I did a bit of XRD and thermogravimetric analysis. So the first 2, SAM-EDS and thin section petrography, that's what I've brought over here to apply it to ceramics. Because I quite enjoyed the thin section petrography when I did my master's. So I thought, yeah, why not?
All right.
Okay. Very nice.
You want to close?
Do you have another question?
No. Alvin, thanks very much for chatting with us. You've talked to us about ceramics and how they have been used throughout at least to some degree, how they've been used throughout history. You've also talked to us about how you personally are studying the raw materials that are used to create the different ceramics in this region. So we wish you all the best in your research, and we enjoyed this conversation very much.